Thank you again for joining with us. That is a lot of incredibly interesting information. You know, I certainly learned something new. I hope and trust that you guys learned something new as well. Maybe saw a piece of data that maybe challenged a notion that you guys might have. There's a lot of exciting stuff going on. You know, I like to think of GFRP rebar as sort of an undiscovered country. My folks I work with are going to roll their eyes when they hear me say that, because they've heard me say it before. But I say that not in a sense that it's the wild, wild west, that this is a dangerous place to go, but I say that in the sense that there are so many opportunities and applications for this technology out there that are waiting to be discovered. Applications when compared to steel reinforced concrete that really have profound economic implications. I mean, there are some incredible things that we're doing and that we're seeing, and it's just waiting to be discovered by you guys, by us. So with that said, I kind of want to go over some projects. You know, what's this look like? This is not just an interesting white paper on the internet, right? What's this look like for the everyday contractor? What's this look like for some actual projects? Now, what we've done and what I'm going to glance over here with you is some projects that we have done. There's two kinds of projects I'm going to discuss. First being a project from the beginning that has been designed as FRP reinforced concrete, right? The second kind of projects I want to discuss that we've done is projects that are designed as steel reinforced concrete that we are value engineering into GFRP projects. And those are those are so special, guys. We get so much data points out of projects like this. You know, with having one project designed for steel, also having a GFRP rebar design, I mean, just the information that can be mined from that, and to really, you know, equip us with the information to really, you know, seriously evaluate, you know, how important this technology is. I'm really excited. So first up, though, I want to hear from a contractor. And so we have a contractor testimonial for a gentleman who worked on a project. And so we'll jump into that.
So the FDOT hired us to do repairs here because they had some spalling and corrosion that occurred in the tidal influence zone because salt water impacts that area the most. This part here, you can see the thickened slab. So here we use number 6 bars for our verticals and number 4 bar for our horizontals. It was so much easier to install compared to regular rebar because it was so much more lightweight. We had to tie our divers off, and if you're dealing with big heavy bar in this area and you have a mat and you have divers in the water trying to put it in place, it makes it extremely difficult to handle that heavy weight. So this project was my first encounter with the GFRP bar. Since then, we've been using it on other projects. It was easier to cut. We were able to take it with a grinder and cut it much faster than regular steel. As a matter of fact, by the time we were done with the project, my guys said, I wish we could use this on every project. It's so much easier to work with and it's so much lighter. And when we were pre-tying cages, we were able to set it in the water with our divers. So we had no issues with any of that. Steel bar, we would have.
Yeah. So a big thank you to Mike for providing that testimonial. But But moving right along, constructability and best practices when using this material. You know, what's the actual nuts and bolts? What's this going to look like right there on the job site? We've already mentioned one big difference, field bending, just by the nature of a thermal set resin, right? It's made with a thermal set resin. Just by the nature of thermal set resins, there's no field bending with GFRP rebar. That means all of the bent and fabricated rebar pieces, regardless of manufacturer, are to be made at the factory level and sent to the job site or to the distributor for, you know, stocking shapes and whatnot. Field forming of large radius curves is possible with GFRP rebar. And there are some authoritative formulas to be able to keep that within the bounds of serviceability of the actual bar. Cut GFRP with a diamond blade, we would recommend that. Do not shear GFRP rebar. I've seen some contractors get bolt cutters and cut the stuff. You know, don't do that, is what we would say to the contractor, because we don't want to damage any of the load bearing fibers going, you know, deeper into the bar. So if you shear that with a bolt cutter, obviously that could you know, give some performance you know, issues. So but with diamond blade, it's going to cut right through the stuff. Moving on. So the bent bars, like we've already talked about, it's got to be preformed in the factory. Some key considerations as performance varies from manufacturer to manufacturer. So again, I'm gonna hit this topic time and time again for the A&E community. You got to know your design criteria, and you got to know how to communicate or specify that for the contractor. Okay, so get to know some of the manufacturers, get to know some of their capabilities, and design accordingly. So currently, some of the quality control, quality assurance currently qualifies bent bars at the bent and straight portions, and you'll see that in ASTM D7957. All right, so steel ties and supports are acceptable unless otherwise specified in the plans. What I'm talking about is one of the #1 questions I get from a contractor. How do I chair this stuff up? How do I tie the stuff? Well, if the project isn't completely non-ferrous, then the answer to that is, well, how do you tie up and how do you chair up steel? But of course, you know, plastic non-ferrous rebar ties and supports should always be made available as well, right? So, and GFRP is typically 25% the weight of steel. So one thing that we see on a real world constructability is that floating can occur in some high slump or areas that vibration is used within concrete. That being said, that's not an issue for the contractors, because all you do is you just make sure that you use adequate ties and fasteners in those areas of concern, right? So up next, concrete cover. We're going to jump a little bit into that again. So concrete cover, it's a big deal as long as David Lai submitted to us, as long as fire resilience isn't the governing design criteria for the member, then by all means, there's no need to use additional concrete cover like we have to do with steel rebar. We got to put a Band-Aid on steel rebar, guys, but for GFRP, it is not so. And again, provided that fire resiliency is not a governing design criteria. So these are a couple of examples. One is from ACI, one is from AASHTO, but this, the only reason why I put these up here is just to show that there is codified authoritative guidance on that for us. So this really isn't, okay, this really isn't the wild, wild west. This is the real deal, guys, right? So the value engineering process, as as we do it. Now, this isn't going to be, this will be different from company to company, but the value engineering process, some of the key elements to that, communication and planning, obviously, surprise, surprise. So know your contractor's timeline, absolute necessity. And know the project's submittal process and approval process. Who's the authority here? Is it a DOT project? Do I need to submit this to the central office? Is it a developer making a new development for single family residences? In that case, that would be, we would see IRC as the authority. Where is it being done? What's the jurisdiction? So we got to know the submittal process and approval process. And then our second step is we acquire the structural drawings, the project plans, loading info, any additional information. All information helps. And then what we'll do then is, after looking at the loading information, flip the design away from steel design, away from a 318 design, and provide what we like to call at TUF-N-LITE the red line marks. And what we mean by that is we'll take the drawing and provide the FRP design for that specific load, right? And then other deliverables could include stamps, and that kind of ties back into the submittal and approval process. Perhaps a stamp is required, right? Placing documents, it helps the contractor. We're very passionate about making this technology approachable and making it easy for the contractor to try it for the first time. Updated CAD drawings is another service we offer, and then material estimation is another service as well. So that's in line with some of the deliverables. And then start to finish, gotta provide support to the contractor, the EOR, the local building office, and then the structure owners, because the reality of the matter is the real winners when we can successfully flip a project from steel design to GFRP design. Sure, the contractor saves money, great. Sure, they get it on time, and while they're still waiting on their truck of steel mesh or whatever, that's all good and well. But the actual winners when we're able to do this is the structure owners, guys. They're the actual winners because they're going to have an end product that's going to last significantly longer. So one quick project highlight. We're running out of time. Thanks to guys again, but we had a 300,000 square foot commercial warehouse, steel reinforced concrete design. It utilized rebar sizes 3, 4, 5, and 6. The value engineering was driven by the contractor. The contractor wanted some options. He wanted to know, what can we do? What's the state of the art right now for this fiberglass rebar thing, this whole thing that I hear about and see. So he reached out. He promoted the idea to the EOR and the owner. The owner loved it. The EOR, we did a lunch and learn with the EOR to bring them up to speed on some of the design codes, right? And I'm pleased to say that they've designed maybe 4 or 5 since this project, 4 or 5 projects that wouldn't necessarily necessitate a non-ferrous reinforcement. But they did so because, after really diving into the information, they see this isn't just a niche reinforcement. This is something that we ought to think of rebar, and then we ought to think of steel rebar, right? You see how I've worded that and phrased that? This GFRP rebar is rebar, or you can go with that rusty old steel rebar. You see what I'm saying? You see the way we're thinking of it and wording it. But anyway, so we did the value engineering, and we provided a high modulus GFRP design, and we, which is very important to specify when you're designing with this stuff, guys. Let us know, is this, what's the design criteria? What are the minimum requirements of the bar that you're designing with, right? All the steel rebar was replaced by a single-sized GFRP rebar. So there was a single size GFRP bar that replaced steel size 4, 5, and 6. We think that's a pretty profound thing in and of itself, right? The bar as an ESR under the ICC evaluation service report program, which made this applicable because this was commercial concrete, right? So the ESR was applicable to the IBC, right? So that's where we find that. So the 11,127 pounds of GFRP rebar, which by the way would fit on a pickup truck and a trailer, right, was more than sufficient to completely reinforce this 300,000 square foot warehouse, which replaced 79,194 pounds of steel. In other words, 2 truckloads. All right. So what are the real world applications of this? How about we get those trucks back on the road delivering something else, boosting some circulation in this country, and we delivered this on a truck and trailer. I mean, you guys see where we're going with this. The implications are huge. The contractor saved 19%. He got his steel quote and he got his quote for GFRP. He saved 19% compared to the steel package. And that was sold through distribution, by the way. I say that just to point out that that went from manufacturer to distributor to contractor. So that 19%, that I say that just to qualify that and to put that into perspective, right? Oh, yes. Yeah, we got to jump into the, yep, perfect. Hey, there we go. There's the end. So we got to jump into some questions now. I know we might have some questions online.
Has there been any evaluation for the use of this product in post-tension slabs?
Alicia, you want to answer, Josh?
Oh, hey, we'll pass that around. Alicia, you want to?
Dave, do you have an answer? Elevated post tension?
It actually behaves really similar to post tension. So it actually is a great complement for the minimal steel you need to add to the post tension. So you get a really well performing for crack control, even though post tension doesn't really crack. The temperature and shrinkage still, it's a great opportunity to keep your slab thickness or your slab weight down. But not necessarily side-by-side comparison in a test. We don't see that, but there's nothing that would keep you from using it as your minimum reinforcement around your post tension.
So we have a question here. It says, does GFRP have any limits when it comes to deep drill shaft construction? For example, is there a maximum depth where GFRP would not be favorable? Dave, do you have any idea on that one?
So if it's an issue of production length, there's no limit as to how long the length of rebar that can be produced. If it's something that has to be very long, the rebar can theoretically be wound on a coil. I have to be very cautious about putting it on a coil, and because it does tend to snap back fairly strongly. But that is one way that can be done for a deep shaft. But also the other thing you can do is you can overlap the smaller lengths of rebar the same way that you overlap with steel.
Right.
So both options. So the answer to the question is really no. Okay. There isn't any limit that way.
Thank you, Dave. Is there a published study that shows the results of the cold temperature effect per the ASTM E23? David Lai.
Well, it was an internal MTO testing report. It was not published publicly, but I mean, if anybody is interested, you can contact me, and I would have to seek approval from the Ministry of Transportation of Ontario to share that.
Okay. Excellent. You have an answer, Alicia?
Yeah, the bars I support, we do have third-party testing for basically low temp. So low temp and high temp have all been tested of the bars.
Okay.
So you can ask the manufacturer, they might have internal third-party testing as well.
Okay, thank you. Same type and size structures, what is the price difference using GFRP as opposed to steel rebar? Is it less expensive to use GFRP? Says same, in other words, structure to structure, what's the comparison steel to GFRP on pricing?
You know what, comparing, yeah, right. Comparing pricing with, from steel to GFRP is often convoluted just on a unit per unit basis. Really the best, I like how that question was posed because the best way to truly compare the pricing would be to compare it project by project.
Right.
But we're finding that within the state of the art currently, this is not your first generation GFRP from the 90s. This is
Let me add to that real quick. I
Yeah.
think maybe stick for stick, we're going to be slightly higher currently on some areas with steel presently, right? But that could change quickly. But if you're going to go through value engineering or you're going to engineer it at the beginning, you're going to find yourself using a lot less smaller sizes and less rebar like we've talked about. Do we have a question come up? You want to use the microphone?
So my question is from Alicia or from this friend. I'm a PhD student at University of Miami. We are designing first building with GFRP, that is 3-story building. I have completed its design, but the problem is owner wants on the first floor, he wants no column. So my span becomes like 40 feet and the beam that I have to provide on the first floor, it becomes 42 inches deep, and that's significant. So I don't know how can I make that depth smaller. One option was using CFRP or something else. So can you suggest anything?
I do a lot of hybrid design. So I will do the beam, so steel, just to minimize size and keep the beam as small as possible. And then I use GFRP where it does extremely well is crack control, temperature and shrinkage steel, and those type of applications. I find that if you do 100% floor, you have to be very careful because it'll be bouncy. It meets code, but designing homes for 15 years, a bouncy floor is not a happy homeowner. So you have to go even more stringent on your deflection on a floor. And I find that steel still does a better job. I'm hoping that we have further opportunities to do more research on combining. I always say it's a hybrid system is an engineer using their brain to give you the best solution. So if you're doing 100% GFRP, you might need a little more bar in order to get the beam size down. So more bar, less concrete.
I used 3 layers even, but I could not decrease much of the depth. I would love if I can only put GFRP there because we are using 100% GFRP, and I want it to be a first project that's using 100% GFRP and not using any other reinforcement. But I don't have any option now.
Exactly. They do really well when you bundle them as well. So using multiple bars to get a larger cross-sectional area is very well. It's because the bond's so great on the bar, you can actually bundle them and kind of treat them like a post tension. That's another option is look at a post tension and then all the supplemental still being GFRP. That works really well with keeping beams small.
But doing post tensioning and all that, I think for GFRP, we have anchorage problems, or I think.
Well, no, with a standard post tension system, precasting, precaster would be a lot better option to get that beam smaller. So that could be, it's still using concrete and GFRP, looking at a precast option for the beam.
Sorry.
No, I think we tried 3, but we are still considering different things, but we are not done with the final design. We just moved towards CFRP. I think we utilized last time was 3.
Because one of the ways you can take advantage of the GFRP has way higher tensile strength, but lower modulus. So one of the ways you can actually help that situation is by separating out the layers more, is that you're taking advantage more of the tensile strength. And that helps offset the reduction in the elastic modulus.
I think we better take our last question here too, but we're getting a little over time. We had only one last question online here, and that said, is it possible to weld or rivet GFRP bars onto other steel members? Or is there any current evaluation regarding this type of joint? I don't believe that currently we can do that. I might be wrong if someone wants to correct me, but welding or riveting GFRP to steel bars, is there any way to do that?
Well, no,
Yeah.
nor would you want to.
Right.
There is no issue with lapping. So you can lap if you've got a
I mean,
bar
steel to GFRP.
to
laps,
GFRP,
but
yes.
not
So,
welding or
and you're
riveting.
obviously going to use the most conservative of the 2 lap lengths, but that is part of the hybrid system. I do a lot of, yeah.
All
So
right.
you do the wall dowels to wall reinforcement, and they can be 2 different materials.
Any research on epoxy embedding, like with the whatever epoxies are on the market, Hilti, you pick
Yes.
one.
Yeah, we've done a lot of research with Hilti adhesives. And they're basically, there's the Hilti adhesive with the, especially with the major surface deformed rebar. Well, the bond strength is so great that it actually will shear the adhesive. So it's way higher than steel, at least 3 times higher bond strength with a post-installed Hilti adhesive. If you'd like the actual test results, we can send you the third-party test results on that.
Well, on behalf of ACI Central Florida chapter, thank you guys for coming out today.